Hello, everyone. Good afternoon. It's a pleasure to be back here on stage at this lively event once again. And once again, I'll be talking about what we work on in the technical committee of the LoRa Alliance, how we do things, and how you can help us. So this whole story started with the introduction of a new physical layer called LoRa, which has been a perfect fit for the needs of LPWAN, providing long range by consuming low power, the precise need of battery operated IoT devices. And just like any RF technology that's good at what it does, people start building proprietary stacks above that, like the link layer, the application layer, and so on and so forth. Well, then came the LoRa Alliance. In order to make any IoT technology successful today, you need to have an ecosystem, right? No single company can crack this problem. There's a huge amount of integration needed. There are many components to this equation, and the ecosystem is the key. And the way to get an ecosystem is to have open standards, right? That's where LoRa Alliance came into the picture. The companies behind LoRa technology and its supporters said that we need to start an alliance and have open standards. That's what gave birth to LoRaWAN 1.0 specification, the standard link layer designed and published by the LoRa Alliance. And that started the ecosystem. And obviously it didn't stop there. The next step was to keep building it, right? Starting from a single protocol over the air between the end device and the network, we started building the whole end-to-end system that involves several different network elements that you will be hearing today and tomorrow: network server, joint server, application server. And marching into the application stack, commonly used application stacks like Zigbee, DLMS, wireless and bus. And below the LoRaWAN layer, supporting different regions and all that. So three-dimensional expansion has started, and that meant even bigger ecosystem. Now that we decompose the system into various components, individual companies can come and say, hey, I'm going to build an application server, I'm going to build a joint server, and they would have a place in this ecosystem. And you know what that means? That means producing even more amount of documents. Now, if folks have ever looked at 3GPP or IETF, you would know they have like thousands of documents, okay? Well, luckily we are not there, and hopefully we will never get that far. We really have to keep this simple and low cost and everything. But nevertheless, the number of documents are increasing. So from now on, when you are looking for a document, well, we started designating them with certain numbering scheme, like TS01, TR02, etc. First of all, we recognize the fact that having started with the standard specifications, we also needed technical recommendations, TRs. A TS is your standard spec. That's very essential for interop, like the LoRaWAN link layer, the backend, the FODA, right? This is our way of telling the industry, if you want to carry application payloads over LoRa, this is the way to do that. Implement the layer 2 spec, right? And we call that TS001, right? And TRs are more auxiliary documents. These are our way of guiding the industry to use our standard specs in the most proper way. For example, the FOTA process summary, right? It's a technical recommendation, and basically it describes how you pull the fragmentation protocol, the multicast protocol, and the application layer sync, and then run these protocols in a particular sequence to achieve firmware update over the air. It's a TR, meaning that this is one way of doing it. You can mix and match these protocols with other things on your own in other ways. We're not really telling you how exactly you should do it, but this is one good way of doing it. And then we also have the regional parameters documents. They are designated as RP. So don't be surprised if you see such designation when you download the next set of documents. And as the documents are growing, obviously, the team behind that is growing. The technical committee is having more and more participation. And doing everything in a single thread is no longer scalable, right? I mean, having one track of meetings, we cannot get to everything, and not everyone is interested in the same subject. So then we started creating working groups under the technical committee, like security working group, regional parameters, FOTA, roaming, etc. And up until now, only the contributor level members and the sponsor level members could be participating in these activities. But starting from this year on, even the adapter members will be able to participate in the working groups. Still, adapters won't be able to participate in the committees like TC and won't have a voting right, but they would be participating in the working group meetings. And that's a great opportunity for us on the LoRa Alliance to tap into your expertise or bring your expertise to the Alliance. So we're hoping some of you will already move forward on that. And we're hoping to see your faces, your participation in the working groups. And then, majority of the year, we have focused on the LoRaWAN Layer 2 104 spec. Now, you might wonder, 104? Well, we were on 1.1. What is this? Are we going back? Well, here's what happened. We did 103, and then we also did 1.1. We shipped 1.1 like a year and a half ago. But then, here's what we realized. We realized the industry mostly did not make the jump. Even though we shipped the spec, we did not see people adopting that. Why? Because there are a bunch of new features in the spec, and the industry kept still working on 1.0 track. Then we said, okay, maybe we went too far, so let's turn around, let's go back and bring some of the goodies from 1.1 back to 103, and do a lot of clarifications, editorial things, to polish the spec and drop in a stepping stone between 103 and 1.1. So we're basically coming back and holding hands, and then we'll take the ecosystem back to 1.1 again. So you will be seeing 104 spec available in about a month or two. And meanwhile, TC is mostly done with the specification. It's going through IPR review, and there's even a reference implementation. Now we're waiting for certification program to be available. And meanwhile, the technical committee has already resumed working on 1.1. We have a bunch of CRs that we've been processing. So 1.1 is not forgotten. It's been just put on hold, and now we resumed working on that. But I expect to see 104 coming out in a couple of months. And you wouldn't see drastic changes from 103. So it's just small amount of changes, but they are meaningful enough to cut a new release. And another new practice we adopted is, starting with the 104 specification, we won't be just shipping specifications. I mean, until now, we were shipping specification and then certification. Now, we will bundle the release with the specification plus reference implementation plus certification. So by the time you have the spec in your hand, you'll also have a reference implementation. So now that's good in two ways. For us in the Alliance, having the reference implementation done before releasing the spec ensures our spec is good quality, right? It's not just Microsoft Word document, it's something implemented. If there are any small bugs, they get shaken out at the reference implementation phase. And from your perspective, given that we are gating the release of spec by a reference implementation, that's also accelerating the availability of the reference implementation organically, right? So this is a new practice, and expect to see this happening on any future link layer specifications. Good old roaming. Now, if you have looked at the details of how roaming works, actually this is not vanilla roaming, right? We have really something extremely special going on with LoRaWAN. Now, we have this thing called microdiversity. When a device transmits an uplink frame, that frame can be demodulated by several gateways at the same time. And those gateways may belong to different network operators. So what that really means is your device can be simultaneously roaming with multiple networks and even be at home at the same time. None of the other technologies have such a feature. And what does it really bring us? Basically, the net effect that this type of roaming provides is network densification. So if there are 5 networks in here, through LoRaWAN roaming, those 5 radio access networks act like a single radio access network. All the gateways receive the uplink, and then they send it to the same network server and to the application server. So without investing in new radio infrastructure, we allow networks to collaborate and collaboratively build denser networks. And as the networks get denser, that basically kicks in the adaptive data rate functionality, which allows the devices to transmit at a higher data rate at a lower power, which saves them battery. And then it reduces the interference in the network for everyone, and it improves the JLOC capability. So it's just a great feature. Now, up until now, several network server vendors have already implemented roaming, and there are 7 networks that are doing roaming today. Mostly public, including one private network. So we have a case of public to public and also public to private network roaming. And majority of them are using roaming hub. So roaming is operational. People are doing roaming using LoRaWAN. And by getting this out, we're also collecting feedback from the market. For example, when we developed the backend spec, for the usage data records, we only counted number of frames, right? Then operators, as soon as they started seriously looking at this, they came back and said, oh, you know what? Counting frames is good, but not enough. We also need to count how many devices have visited my network, right? I need to have the device count. We said, great. That's a great input. And then we processed a change request, a CR, got it accepted, and now that feature is in. So we have this philosophy of a minimum viable product in the LoRa Alliance. You know, we as engineers, we can design crazy specs, but if they're not going to get used, they can only be harmful. So instead of doing things on our own, like, you know, in a free spirit, we get something out, we see it gets implemented, adopted, people build experience, and then they come back and say, what's missing? Then we build that. And that's really important for bootstrapping a young ecosystem like the one we have. And what's in the pipeline is the backend interface 1.1 spec. Now this spec, the new feature we have in that spec is the JLOC roaming, meaning that even when the device is roaming abroad or into other networks, we'll still be able to get the JLOC information sent from visited network to the home network. That's really essential for trackers. And a bunch of refinements. Now, this spec has been semi-frozen. What's that mean? Well, as far as TC is concerned, it's done. But we're still awaiting the very first implementation experience. We need one vendor to come and say, I have implemented it, it works. Or I have implemented it, and here are the bugs. And we'll deal with them, fix them, and only after then we'll go through this IPR review of 2 months and get this published. Another goodie we got out of the backend interface spec is the remote activation. So in LoRaWAN, we use symmetric key cryptography. The reason is, due to the constraints of the sub-gig ISM, we cannot use public key crypto. So using symmetric key crypto means there's a root key on the end device, and an entity on the network side should also have the same root key. Now, if you put that root key in a network, like a network server, that means the device has to be personalized or customized for that one particular network. And that's not a good thing for the manufacturers, right? They want to build devices that can be activated anywhere, right? They don't want to customize their device for a particular network from out of the manufacturing. So this is where the separation of a network server from joint server comes into the picture. Joint server is the trust anchor where the root key or keys are stored. And by separating that from network servers, now the device makers can build a device that would be personalized against a joint server, but that can be activated across several networks, as long as those networks do have an interface with the joint server. And as of now, we already have multiple vendors with joint servers that are available commercially. And the firmware update over there, another big feature that we're proud of, because not every technology can do that. And we not only do it, but we do it extremely efficiently. How? We rely on physical broadcast, right? When we're pushing, say, firmware to all of you guys, imagine you are the devices, we don't have to send it like one at a time, but basically we do a physical broadcast, right? So that helps us use the air resources in the most efficient way. So in order to progress this work, we obviously encourage vendors to implement that, and then we have gone through interrupt test. In the photo working group, we have a test specification. These are interrupt test specs. And so far, 7 companies came forward. We had 10 sessions, a mix and match between the client side and the server side, covering 3 regions. And through those tests, we have basically shook down any bugs that we could find. So that went well. And we also published a process summary document. Again, you have the building blocks, like the fragmentation, the multicast, and app layer sync. And here's how you would use them in a sequence. And in the pipeline, we have the revisions of the fundamental building blocks again. We also have a firmware management spec. This is another application layer protocol that helps us manage the firmware file on the end device, like checking its version, deleting it, or rebooting the device to activate the new firmware. And while doing this exercise, we also built some good experience around how to build applications for LoRaWAN. So in order to provide the guidance on that, we started working on app layer design guidelines. So any future application layer protocols we would build in TC would be following these design guidelines, which is based on the experience we built in photo working group. And multi-package access, which deals with how to run multiple application layer protocols and manage their efforts and all that. Now, security. The FODA that I just talked about, in fact, believe it or not, it's one of the tools in our toolbox of security. But just to take a step back, what we have for security for LoRaWAN? Well, we have all the bells and whistles any modern wireless communication needs. We have mutual endpoint authentication, data origin authentication, replay protection, integrity protection, and data encryption, and all using AES 128. That means we are using 28-bit keys and 28-bit cryptography, which is practically, it cannot be brute forced, okay? And this is the state-of-art security. And then what FOTA brings us is insurance. Say you shipped a device, and then just the next day you discover there's a glitch, there's a bug at your application, right? How are you going to fix that? You cannot go and collect the device back to your lab and then fix them. Through FOTA, now you're able to patch your devices in the field, okay? Again, any modern, especially IoT solution needs to have FOTA. Without that, you're taking a huge risk. And if putting the keys in the software is a risk for you, then we say, okay, you can use a secure element on the end device. You can use a hardware security module on the network, and then you can enjoy hardware level security. Now, what that gets us is the communication technology security. But at the end of the day, having an overall security or the solution security depends on a few other things, like having a secure implementation and having a secure deployment. Only when you have a tick, a check mark for all these 3, then you can claim your solution is secure. For example, we jump a lot of hoops to make sure we have a secure technology. But at the end of the day, if you guys build a product and put your app key, the root key, in the source code and publish it on the internet, we cannot do anything to protect that, right? So this is implementation security. Or if you build a device and put the keys on the QR code on the device, we cannot do anything about that. So the problem is, quite often there's confusion about one and the other, right? People hold the device, they realize there's an implementation flow or a deployment flow, and then they say, oh, LoRaWAN is not secure. That's not true. The LoRaWAN as a communication technology is secure, but the issue at hand is either an implementation or deployment. And this is exactly what we are seeing a lot, including a recent publication. I'm sure you guys have noticed that. And the regional parameters. So we have published regional parameters document RP002. What is significant about that document is it provides one common regional parameter spec that is applicable to any current and past versions of the layer 2 spec. In the past, we always generated a regional parameter spec for each version of layer 2, like one for 102, another 103, another 104. But moving forward, there's just too many documents to handle. We have single document. In that, we're able to address all the regional parameters needs of the past and the current link layer spec. And extensive clarifications, as always, went into that, and an improved CN, the China region. And in the pipeline, what we have, which I think you'll be able to see within a month or a little more than that, is a revision of that document that brings Indonesia, Vietnam, Philippines, Israel, and Cuba support. And the application layer, that's another area that we have been marching into, because if we just standardize the PHY, the MAC, and if the application layer is in the wilderness, we still fail interop. Now, up until now, people have been building proprietary application stacks, which is good. It saves the day. But moving forward, in order to unlock even larger ecosystem or reduce the pain of integration, we said we should adapt existing application stacks, right? The most obvious one is IP, but IP is too big to carry over LoRaWAN. So we went to IETF and started collaborating with IETF. And IETF LPWAN working group specifically defines a super compressed IP over constrained links like LoRa. And the SHIC is the protocol for that, which not only brings us the ability to transport IP, but also uplink fragmentation. Remember, we already had fragmentation, but that was for downlink, for FOTA, and similar broadcast technologies. But for uplink, we did not have a solution. So through SHIC, we also get uplink fragmentation. And we are using this especially with DLMS. So we have been also working on adapting the DLMS stack over LoRaWAN. And we've been working with DLMS UA, and there's even a white paper that you can download from Resource Hub. Similarly, wireless M-Bus, we initiated this work. Both DLMS and wireless M-Bus, we should be able to finish within this year. And wireless M-Bus is worked in a collaboration with OMS. And then the question is, what's next? Well, actually, there's a question from us to you. What next application stack would you like to see? Again, we want to make sure we just don't arbitrarily pick and choose app stacks, but we can build things that would have a market or a consumer. So with that, in a nutshell, as you see, our architecture is expanding in multiple dimensions, and our external engagements are being enriched, working with IETF, DLMS UA, OMS, and the process and specs are being refined based on the input we're collecting from the ecosystem. And once again, I'd like to emphasize, so now we have more chances for people to participate in the LoRa Alliance activities. So even as an adapter member, you can participate in the working groups, and I would like to welcome, and I'm hoping we'll see at least few faces from this meeting at the next working group calls. With that, I've reached the end. I'd like to thank you, and I can get some questions.
Thank you very much, Alper Yegin. Yes, we do have time for some questions. So if you have one, please wave your hands and I approach you with the microphone. And if you don't have questions, I have some. No? Okay. I've been watching, and I'm not a real techie, but I got this question from the audience saying that LoRaWAN 1.1, 1.02, 111, 104. If I would design a new end device, what specifications should I follow?
Yeah.
Because the 1.1 It's still the implementation needs to be validated.
Right.
But which version do I use?
That's a very good point. I mean, this is an area we certainly need to improve. There's like Chris said, there are like many versions around, and which one to pick and choose, right? So the quick answer is today, as of today, the stable version we have is 103. Okay, 103 is the one that has like full support. So if you're building a device today, it's 103. But like a month and a half or 2 months later, when 104 is out, then you would bump it up to 104. And then we're still working on 1.1. There are some bugs. So later in the year, it would be 1.1. Now, the problem is like, having to explain this nonlinear thing, that it shouldn't be this way, okay? We're working on a document to guide the ecosystem, how to pick and choose, and so let's take, we have this action item, not having to go around and explain all this verbally.
Oh, we have additional question, probably also on the version. Yes. We're pretty close to the, if you come here. Yeah.
Hello. What is 2.4 gigahertz LoRaWAN? 2.4 gigahertz.
What is or when is? What is the question?
What about 2.4 gigahertz?
Right.
LoRaWAN specification.
Right. Okay. So at the moment, we're going through a process of collecting new project proposals in the alliance, and 2.4 is one of the proposals at the moment. Now, the process is still ongoing, so because we haven't reached the end, I won't be able to tell you whether it's on board or not, but it's one of the candidates. We just have this prioritization activity because there are a lot of features that are coming into the LoRa Alliance, and even though we look like a big crowd in here, actually we're at the infancy of this ecosystem. And as such, we have to really respect the capacity of the ecosystem in absorbing new features coming at them. And for that reason, we're going through this prioritization activity, and 2.4 is one of the items in that. But that's all I can say at the moment. So it's on the table.
Okay.
Thank you.
One final question, anybody? Well, then I have one.
Okay.
The specifications on firmware updates over the air. It's been published about a year ago, something like that. Do you see some implementations already or not yet?
Yes, definitely. I mean, a lot of metering deployments, for them, there's a hard requirement to have photo, right? Because these devices, they are very highly valuable devices in the field. Once they're installed, they stay there for like 10, 15 years. And it's a valuable asset that people, I mean, the utilities want to make sure if there's a problem, they have to be able to fix it in the field. So especially for the metering, it's almost a hard requirement to have FODA. And we're seeing a lot of action in the metering in Europe, in Asia, in US. So yes, that's where we see FODA heavily.
Okay, very well. Thank you very much. Alper, Yegin.
Thank you very much for listening.